If you're looking for the second episode related to Kubecon London, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is a bit special. It's going to be related to Kubecon London 2025. If you pay attention, a few weeks ago I released the first episode sharing the news about cloudy projects, Observer Day, and of course the atmosphere of KubeCon. In this episode here, I'm going to focus mainly on KubeCon and share 3 interviews. The first one will be related to Fluentbit 4.0 and the news related to the project, and especially the support of traces. The second one will be related to profiling, so news about the project, see how we can use it, the type of support we have, is it experimental or not, so we will answer all those questions through this interview. And last, if you are looking for a solution to monitor your network, there's another OpenTelemetry project that is doing this type of work. It's called the Network Collector. So Jonathan Perry will explain what it is, what type of signals we're going to collect, and he's also working on another project that is very interesting to monitor your noisy neighbors. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in London. Here I come, KubeCon London. KubeCon Day 2, equipment setup, now ready for live stream and interviews.
I'm a maintainer of Fluentbit. I've been with the project for the past 3 to 4 years. I work closely with Eduardo and the rest of the team and trying to drive Fluentbit forward and attend to the community as a whole. One of my main interests is driving the collaborations from the community to try to empower those who are interested in getting involved in the project. This year we have some very interesting features for you. We have things for everyone. We have more integration with the OpenTelemetry ecosystem. We have, in this part, we have added a new processor that's specifically meant to handle traces, to reduce the volume of traces that you are processing and thus delivering to your endpoints. This one is interesting. It has 2 operation modes. You can do probabilistic tracing, like storage of the traces, but you also have a very powerful conditional mechanism that you can, in which you can use the actual context of the spans that comprise the trace to determine if that's some information that you want to keep in your storage or not. I would like to encourage you to give it a try. We have a very nice workshop put by our coworker Eric Shavel that has this and much more, and I think you will find it very useful. In a different arena, we have a new integration with the Zig language, which is very interesting. It will allow you to write your plugins in this language. Those are native plugins, so you will be able to get the most out of the performance of your system with the smallest overhead possible. And we made a point of making these into something that's very idiomatic and something that actually belongs to the Zig ecosystem. The idea is to make it very comfortable and very natural for the users to write their plugins using Zig. At the moment, we only have support for Zig as in the output plugin system, but we will extend these to support input plugins and processors in the coming weeks or months. A different feature that I think is more useful for all of the community is conditional processing, because processors, as you may know, allow you to scale your deployments to a much larger degree. But there was a caveat in which everything that passed through the processor stack was processed by the processor stack, and that had its own complications. So now we have introduced the conditional processor system, in which you can define some conditions based on the context of the data that you are manipulating, which will allow you to scale to a much larger degree. And the last one I'm going to mention here is that we have lifted a historic limitation that we've had of 256 output plugins or routes. So now you can scale up to whatever your hardware allows. That's one for the hyperscalers, which I've had conversations with quite a few. So I think that part of the community is going to be happy about this. When it comes to sampling, there is a constraint of memory, of course, because the idea is that when you do tail sampling, in which you define these constraints as to which data you want to keep and which data you want to discard, what's important is that you have a complete picture of the trace that you are evaluating. And as such, you have to define a time span of the trace information that you want to save before you evaluate it as a whole, and that comes with certain memory constraints. There is no explicit limitation as to the amount of memory, but yes, I think the time span is what will drive these. You don't need, in most cases, you don't need to store these traces for 30 seconds or a minute. It's just a matter of seconds. So once you fine-tune these to your requirements, you will find that the overhead is not very big.
My name is Damien and I am a member of the OpenTelemetry community. I'm both a maintainer of the Go SDK and I work on profiling, especially data ingestion of profiling. So I'm not working on the low level like profiling data generation, eBPF, those kind of stuff. I'm working on when the data is generated, we send it to a collector, and then the collector can transform it and then send it out to the vendor. That's my focus. Profiling has changed a lot since it was announced as a signal by OpenTelemetry 4 years ago. Elastic has donated a profiling agent, which is a very great bedrock for profiling at OpenTelemetry. We have also merged, it's available but alpha and still has breaking changes, OTLP supports for transmitting, emitting profiling data, which means that we can have an agent that knows the language it needs to emit the data with, so that profiling can be read and transformed, and vendors can then read that data as well to then display it. And we also have collector support. So the collector is able to read, transform, and emit data regarding profiles. In terms of next steps, I think our focus at the moment is getting OTLP support stabilized. So as I mentioned, OTLP is there. You can technically discuss profiling using OTLP, but we have been doing several breaking changes to make things better, and we can do that because we're alpha and that's how development works. But we want to be able to make that stable, so stabilization will mean we don't make any breaking changes anymore, but it also means we can much more easily rely on that protocol. We can build upon that protocol without the risk of having breaking changes that require lots of modifications everywhere. And that will be the biggest step forwards, next step forwards, because it will really allow us to be able to say, okay, now you can start building on top of profiles, because the data you get from profiles is stable. It's not going to change in breaking ways until we have a V2. Our presentation was titled The States of OpenTelemetry Profiling, and we basically showcased where we are now, both in terms of setting up the OTLP format and making it reliable, useful, and performant, as well as a demo of running profiling using the collector. Because one of the things that we have shipped recently is support for the eBPF agent that was donated by Elastic to run as a collector. So instead of previously that agent ran as its own daemon, so it handled daemon stuff itself, and now it's using the collector APIs so that you run a collector and profiling is a receiver. And that means we can reuse everything that the collector provides, such as like receivers, obviously, but also processors to augment the data, and exporters. So that the idea is to export profiling data in OTLP. But if you don't want to send the data to an OTLP-enabled endpoint, you can also send it elsewhere. The thing we showcase is kind of our recommended architecture, which is to have a lightweight collector running on every node. So you need, for profiling, a collector running on every node, because it's eBPF based and it needs to read the data from the node from eBPF. So you cannot do just like one for your entire cluster. You need one on every node. And then to keep following the OpenTelemetry recommendation of having one collector cluster-wide that gets all of your data and knows where to export the data and is the sole or handler of credentials, outside credentials. Our recommendation is that this node-level collector communicates with the cluster-wide collector, which is the same, that is going to handle traces, metrics, and logs, and then sends the data to any vendor that you like. So right now, you have to build a custom collector to be able to use profiling. It's not that hard, but there can be itches because it's not stable yet. So we don't recommend doing that in production. We are going to provide a distribution of a collector, which is going to be lightweight. The idea is that collector sole purpose will be to gather profiling data, maybe transform it a little bit, and then send it. We don't want to make that collector bigger, because otherwise it kind of gives a wrong idea of the recommended way to use the collector at OpenTelemetry, which would be an agent that on every node handles every signal. And the recommendation is still within OpenTelemetry to have like a cluster-wide collector that handles everything cluster-wide, which is better because it allows you, especially with distributed tracing, that collector is aware of the entire trace. Like it gets the entire trace from every service, and it can do smart things much more easily, such as sampling. We have two processors currently enabled. It's actually the main two ones. It's attributes processor and K8 attributes processor, resource detection processor, sorry, and K8 attributes processor. Both those actually do something very similar, except it's for different environments. So the resource detection processor is going to be if you're running on bare metal, and then it's going to detect things like the host ID and augment your profiles with that information. K8 attribute is going to do the same, except in Kubernetes, you're in a containerized environment, so the data does not come from the same place, which is why there are two different processors. Those are very important because it's also the thing that the collector gives us, which is that on the eBPF agent, we can focus entirely on profiles generation. we don't have to focus on data augmentation, like detecting where you are, what's running this, and what is the context of this process. We can rely on the processor and things that already exist in the collector to handle all of that, which makes it much more powerful because kind of, again, as I mentioned earlier with exporters, for free we can support all systems. So OTTL support is landing soon. I couldn't really say when, because technically the PR is ready, but there are still some consensus required, some small things. But the idea of OTTL support in profiling is pretty interesting because then it means you can, like for example, you get profiling data and you can transform it to say, like I'm renaming my profile name or I'm generating metrics out of my profiles. And that's a very powerful way to also use your profiles on the collector, because then like you can generate data into another signal from profiles, which opens up a very large new window of opportunities. So to start experimenting profiles in the collector, if it's your like cluster-wide collector to receive OTLP data and send it back, it's in the main one. Like if you use a recent version, which was published after January, October actually, after October, so after V01120, you can use that collector. It has profiles enabled behind the feature flag. So you need to run the collector with the feature flag profiles enabled. So if you wish to use a collector that is going to gather profiles from eBPF, then you have to build that collector yourself, because we don't have a collector distribution yet. It's one of the things we're working on. So right now you have to use the OCB tool to build a collector and add the receiver, which is located in the eBPF profiler repository, so that it's going to profile your data. So it's not really well documented at the moment, but that's kind of part of being in development. We're going to improve the documentation as we go to stabilization of this.
Jonathan Perry. I'm OpenTelemetry maintainer on the network collector. The network collector is a collector that sends telemetry into the OpenTelemetry collector about network flows, how your system behaves on the network. It uses eBPF and takes telemetry from the operating system about how your pods interact between them and outside to external services, and gives you the ability to look at red metrics, right? Latency, error rate, and throughput. When we started the project, we wanted the collector to work across Kubernetes clusters. Back then there was console. We had support for ECS and of course, running on bare metal or EC2 instances or Docker Swarm. And we've kind of converged a lot more on Kubernetes use cases, although the collector still would work on these other architectures. It's all about getting metadata, getting the right metadata, and then attaching it back to your pods, associating it back. The collector today captures point-to-point telemetry. So if a TCP connection terminates at a pod, you would see metrics for communication between that pod and the other pod. If you had sidecars, then you would see the sidecar communication. And if you have load balancers, you would also see the load balancer. One of the features that we've been wanting to add for a while are the ability to parse the headers that load balancers add to traffic so that you can show how traffic flows beyond the load balancer. But today, kind of the visibility you get is between each pod. Today, the collector mostly exposes metrics, although it has a mode to export logs. And you can think about those as flow logs. And if you need very fine-grained information about what is happening in your system, you could use the OpenTelemetry network collector to collect those. There are other potential sources for telemetry. For example, service meshes expose a lot of telemetry, but the network collector has very extensive telemetry into what the operating system is able to see. So you can see packet drops, SYN timeouts, which are relatively hard to get in the other layers, as well as the latency on the network layer that doesn't take into account doesn't capture the application layer latency. Actually, in fact, you can get the latency with the application layer and without the application layer. So you get richer information about whether the network is problematic for a stream of traffic. We're looking for contributors. The project is relatively stable. I feel it has very good bones. It has a good infrastructure in order to collect telemetry and then aggregate it across multiple collectors and output metrics that make sense and are actionable. One of the major problems that we're facing today is that kernels move on and you need to adapt the versions of the instrumentation to different kernels. And so we're really looking for maintainers to help out, advance the collector and make it support more versions. Right now, the way it's built, we also need some support for each distro. So as distributions change, so, for example, the Ubuntu or the AWS one or the GCP distribution, we need to add support for that so that it's easy and smooth to deploy. I'm working on a new project right now that is exciting to me, and I think the community needs to know about, which is observability into noisy neighbors, where you have applications running on the same physical hardware. You have multiple pods running on your VM, and they interact in terms of performance. So one pod doing some action can negatively influence the performance of other pods. We usually monitor at granularities of multiple seconds. Could be 60 seconds, 15 seconds down, maybe 5 seconds in some system, maybe 1 second. But a lot of the interfering events happen at 1 millisecond granularity. For example, garbage collection can happen, takes between 1 millisecond and 100 milliseconds. And this is completely invisible today because of averaging. As you average out over multiple seconds, this just becomes invisible. So you need to collect at very fine frequency, at high frequency, and you really don't want to output all of that into your database. So what we're building is an engine that for each time slice of 1 millisecond detects if you have a bad condition, and then you aggregate those signals. So you can say, one pod is noisy neighbor to the other pods, this many slices out of a 60-second window. The other pod is that much. The idea is that eventually we'd be able to use the detection signal on an individual slice and trigger mechanisms in order to mitigate the noisy behavior. So for example, reduce the allocation for a noisy pod within maybe 2 milliseconds. Yeah, this is an open source project called Unvariance, and it's available on GitHub. It's called the Unvariance Collector, and we're looking for contributors. Would love to see the community gather around this, and we're also looking at this point for organizations or teams who are willing to deploy the collector, test it out, and tell us what they want out of the collection so that we can create a better experience for everybody.
that's it for today's episode related to Kubecon London, the part 2, where we were sharing a couple of news about Fluentbit 4.0, so very exciting to see the support of traces and moreover to get tel sampling. So I'm very excited about it, so I may do a deep dive about it, see how much resources it utilizes when you start using tel sampling. The second thing is about profiling. So profiling is very exciting to see, so we can already try it out with this collector, deploy the Damien set to build those profiles, and the traditional collector that has already a support for profiles and has a couple of processors to enhance the profiles that we are collecting in the collector. And last, this network collector, I think it's really interesting. So I may also look at it to see what the type of data we are getting, to see if there's any difference compared to other solutions. If you enjoyed this content, don't forget to like and subscribe to the channel. So see you soon for another episode.